tangent of polar curves. The polar equation is given in the form r equals f of theta, but the slope of the tangent line to the curve is still dy over dx, which is not the same as f prime. We can parameterize the polar curve using x equals r cosine theta and y equals r sine theta, where r is a function f of theta. As long as the function f of theta is differentiable, x is differentiable with respect to theta, and y is differentiable with respect to theta. That is, to find dy dx, we can use the chain rule dy d theta over dx d theta. But dy over d theta is the derivative of y with respect to theta. To take the derivative of y with respect to theta, we use the product rule. F prime of theta times sine theta plus f of theta times the derivative of sine theta is cosine theta over dx d theta is the derivative of x with respect to theta, which we also use the product rule. The derivative of the first is f prime theta times the second factor cosine theta plus keep the first factor f of theta times the derivative of cosine theta, which is negative sine theta. Rewrite this as f prime theta sine theta plus f theta cosine theta over f prime theta cosine theta minus f of theta sine theta will give us dy over dx. We can evaluate this dy dx expression at theta to obtain the slope of the tangent line. This derivative can be rewritten as dy dx evaluate at the point r comma theta, which is in polar coordinate, dr d theta times sine theta plus r, because r equals f theta, times cosine theta over dr d theta cosine theta minus r sine theta, as long as dx over d theta is not 0. That is, the denominator is not 0 at the point r comma theta. If the numerator dy d theta is 0, but the denominator dx d theta is not 0, then we would obtain the slope of a horizontal tangent line. If dx d theta is 0, but dy d theta is not 0, then we will obtain the vertical tangent line. We might have to use the limit to determine the vertical asymptotes if we encounter 0 in the numerator and 0 in the denominator, both 0. Remember that 0 over 0 is an indeterminate form. The L'Hopital rules comes handy.